in this video. 1. Find out why work done equals potential energy. 2. Understand the law of conservation of energy. 3. Learn how to solve questions on work energy and power, step by step, not memorization. Stay tuned till the end for tricks and tips.
Welcome everyone to this video. So today we are going to solve 6 questions on work, energy and power. So after solving these 6 questions, I guarantee you there is no need of you going through the notes on work, energy and power, because what I'll teach you in these 6 questions will basically cover the entire topic. So don't forget to subscribe so that you don't miss our daily notification for when a new video is released. So to begin, we are beginning with this question, which is on work and energy. So it says 50 joules of work must be done to lift a vase from the ground up to a shelf. How much potential energy does the vase have when it is on the shelf? So here they want us to calculate what? The potential energy. But remember, when we look at the formula for work done, is equals to force multiplied by distance. And if we also look at the formula for potential energy, which is mgh, you will see that in the formula for potential energy we have mass times gravity, which gives us what? Weight. And remember, weight is the same as force, so meaning work done is equal to what? Potential energy. So remember this, work done is equals to potential energy. Done is equal to potential energy. So if work done is equal to potential energy, meaning our potential energy will be the same as the work. So potential energy is 50 joules. So that's how simple the first question was. So the next question is saying, if the vase falls from the shelf, how much kinetic energy does it have before it hits the ground? Assume air resistance is negligible. So how can you calculate the kinetic energy before it hits the ground? So here there is a diagram which you need to understand before solving this question. So this diagram, make sure you pay attention as I'm explaining. So we have 3 scenarios. 1, this boy is holding, let's say, the same vase. So this is the vase on the shelf. So the vase drops halfway. So this is half. Then here it's what? Before what? It hits the ground. So there are 3 principles which you need to know under energy. So this is the part which is known as the conservation of energy, where we say energy is transferred from kinetic to potential energy. So here at the beginning we have 2 energies. We have kinetic energy and potential energy. Even here we also have kinetic energy and potential energy. Even at the before the vase hits the ground, you also have kinetic and potential energy. Now what are the values? So you need to pay attention. So here at the beginning, since the vase had only what? the potential energy, which was 50 joules, meaning the kinetic energy was what? Was 0. Why? Because the vase was not moving. The vase was at rest. It had no kinetic energy. Remember, I said that kinetic energy, this is the energy an object possesses due to its motion. So whenever an object starts moving, it has kinetic energy. So now the vase has dropped. Now after dropping, it has reached where? The midpoint or halfway. So this is halfway. So meaning, as the ball is dropping, the potential energy will start to what? To reduce. So this potential energy will reduce from 50 to half. So at the midpoint, our potential energy will be half, which is 25 joules. And since the ball is gaining what? Speed, meaning the kinetic energy will start to what? To increase. So meaning at midpoint, the kinetic energy is equal to the potential energy, or the kinetic energy is equal to half the potential energy. Then when the ball, before it hits the ground, the potential energy becomes 0, whilst the ball gains its maximum kinetic energy, which is 50 joules, which concludes our conservation of energy, which states that energy is neither created nor destroyed, but it can be changed from one form to another. So we changed potential energy into kinetic energy. Yeah. So now the question is saying, if the vase falls from the shelf, how much kinetic energy does it have before it hits the ground? So if you have paid attention to my explanation, you have probably solved that the kinetic energy will be the same as the potential energy, which is 50 joules. Why are we saying that the kinetic energy should be the same as the potential energy? Because we say that just before the ball hits the ground, the total potential energy will be converted to kinetic energy. Then at half, we have what? Half the potential energy. So here, in case you forget, just remember, when you have half, meaning you have to divide the potential energy by 2. Yeah. So moving on to the next question, which says, what happens to this energy after the vase has hit the ground? So the moment this vase hits the ground, of course, all the kinetic energy will be converted back into what? Potential energy, because the vase has stopped moving. So here you can say, what happens to this energy after the vase has hit the ground? So the energy will be converted into potential energy. So here you have to write 4. Yeah. Then our final question is saying, state the law of conservation of energy. So how can we state the law of conservation of energy? So the law states that energy can neither be created nor destroyed, but can be transformed from one form of energy to another. Yeah, so this was my first part where I solved the first question on work, energy, and power. So again, the next question will be on the same topic. So this series I've made is for you to help you understand the entire topic using just the question, which will speed up your learning process. So question 2 says, if a stone is dropped as shown below, what is its kinetic energy when it has fallen halfway to the ground? So the previous question was looking at what? Conservation of energy. So basically you have summarized what you need to know on conservation of energy. Those questions are the question which comes. And we also have another question on conservation of energy. So here, for us to calculate the kinetic energy halfway, remember what I said in the first video. We said that at the beginning here, when the stone is in the hand, it only has what? Potential energy, which we can calculate using the formula. But here the kinetic energy is 0. Remember this. But as this stone is falling, here at halfway, the potential energy will be what? Half. So meaning here the potential energy will be what? Half. And also the kinetic energy. So meaning the potential energy which was here will be half when it reaches what? The middle. And also the kinetic energy will be half. Then here, before it reaches the ground, here the kinetic energy becomes what? The potential energy. So meaning here you can calculate the kinetic energy using the formula for what? For potential energy. So this is known as the conservation of energy. We see that energy is being converted from potential energy to kinetic energy without being changed. Meaning if we started with 50 as our potential energy, meaning at the end we'll have the kinetic energy to be 50. You see? Then at the middle, you are both wondering, here we have the kinetic half and the potential half. Yes, if we have the kinetic 25, let's say it's an example, the potential energy here is what? 50, right? Then when the ball is dropping, the potential energy will also drop to 25, but the kinetic energy will increase to 25. Then if we add, we have 50. The energy is being conserved. It is being saved. It is not destroyed. So that's the what? The law of conservation of energy. So now that you have understood what I mean, we can solve now the question. Yeah. So getting back to the question which says, calculate the kinetic energy when it has fallen halfway. So step 1, we need to calculate what? The potential energy at the beginning. Yeah. because we cannot calculate the kinetic energy at the middle if we don't know the potential energy. So how can we calculate the potential energy? So we say potential energy. So we say potential energy is equals to mass times the gravity times the height. So always the gravitational field, we know it's 10 newtons per kg. So this value, don't forget it. This is an important value in physics. Yeah. So we have the mass of the stone, which is 4 kg. So always, I forgot to tell you, write the data always. So what do we have? We have the mass of the stone, which is 4 kg. Second, we have the gravitational field, which is 10 newtons per kg. Then we also have our height, which is 4 meter. We are calculating for potential energy and what? Kinetic energy. Remember, our question is asking us for the kinetic energy here, not the what? The potential energy. Yeah. So here now we put in the values. Our mass 4 multiplied by 10 multiplied by 4. We get what? 160 joules as our potential energy. So meaning our potential energy here at the beginning was what? 160. But remember, I told you that when this potential energy reaches the halfway, it becomes what? Half. And also the kinetic energy becomes half. So meaning here at the middle, our potential energy would be what? 160 divided by 2, which is 80 joules. So meaning here halfway, our potential energy will be, let me write it properly. So here at the half, our potential energy will be what? 80 joules. Then our kinetic energy will also be 80 joules, because we said at the middle the potential energy and the kinetic energy are equal to each other. So whatever the potential energy is, also the kinetic energy will be. Then you have solved your question. So we say that the potential energy is equal to the kinetic energy at halfway. So you have to remember this. So meaning our kinetic energy is equal to 80 joules. Yeah. So moving to our second question, which says the stone on the diagram below slides down a smooth slope. What is its speed when it reaches the bottom? So now this question is asking us or requiring us to calculate the what? The speed. So whenever we're talking about speed under work energy and power, you have to remember that here now we are dealing with kinetic energy. But do not forget the conservation law. Whenever you are dealing with potential energy and kinetic energy, the first thing that should come into your mind is the law of conservation of energy, because that law is what you use to solve basically all the question on this topic. Yeah, so how can we calculate the speed when it reaches the bottom? Remember, I told you that here at the bottom, the kinetic energy becomes what? The potential energy. Yeah. So let's say here we started with Okay, let's solve. So step 1, the first thing we need to do is find what? The potential energy. Yeah. So how can you find the potential energy? Using the diagram we have. So remember, in our first question, we solved our what? Our potential energy here at the beginning.